Okay, in this section, I will go through the Testbench for the sequence detection function. Sequence detection. And in this Testbench, I will use the task. I will use task to give stimulus. As we have two different implementations of the same sequence detection function, so we can check the function of the two by comparing the output of the two implementations. So the block diagram or the architecture for the Testbench is give stimulus, and instance the two implementation. Okay, they both give the same input and with different output signals. Then we will check the output signals to see whether there is function difference for the two implementation. Okay, this is the architecture of the Testbench. So you can treat one as golden model and one as the DUT, design under test, and we will compare the output of the two models to check whether they are functioning the same or not. Okay, let's go through the Testbench. The beginning part is simple, okay? Just define some internal signals and generate the clock and output the waveform. Here I define a task that will give stimulus. So please take 1 or 2 minutes to read this task and try to understand the function of this task. Okay, you can pause the video. I will go on. So the function is there is to input data and enable randomize or disable, and some internal signals counter and shift data. So first the input data will be latched, or you can say will be assigned to the shift data. Then it will use 8 loop. Yes, this loop will execute 8 times. So each time we will drive the D in. D in is defined inside this module here. So we will drive the D in using the MSB of shift data. After that, the shift data will be left shift. Yes, LSB will shift to MSB by 1 bit. Then it will check the input of enable round. If it's true, that is if it's a high value, the EN signal must be defined in the upper level. The EN signal will be given a random value. So the EN is defined as a 1-bit signal. So the result will be randomized to 0 or 1. After that, we will wait a cycle and delay 1 time unit. Okay, this is the function. So the function is shift the data, input data out 1 bit by 1 bit using 8 cycles. Yes, and within the 8 cycles, the value of en can be changed. If en round is 1, the value of en will be changed. If en round is 0, the en value will not be modified by this task. Okay. So let's go. This is the initial block that will give the stimulus to the DUT and model. So give reset value to these signals and wait for some cycles and release the reset. Then we will give some stimulus. So we will first set en to 1 and give the pattern. The pattern is to match head to back. That is back to back. So this one match. Then match again. Yes. So this then we will call the task the output pattern task to send the bit out this bit cycle by cycle and disable the round function. So en will be not changed. En will keep 1 for all the time this task is executed. Okay, for next pattern, we use the pattern. There is just one match. Yeah, but there is many ones before match. Then the second pattern, 1 0, then match. Then the fourth pattern, 1 0 1 0, then match. So the first 4 patterns, they are fixed patterns. That is, the input value and the en signal are fixed and at some sequence. And for the fourth part, for this part, it's random sequence. That is, for this part, we just random the waveform enable and keep the D in the 8-bit D in to 4 defined values. Yes, we have choose 4 special value for D in and randomize the waveform enable. And for the last part, it is also random pattern. And this time, both the input data and the enable are randomized. Okay, then finish. So in this stimulus, as I have introduced before, we usually divide the stimulus to 2 categories. One is the fixed pattern category, and one is the randomized pattern category. We usually use these 2 categories, the fixed pattern and the randomized pattern, to test the function. To make sure we have tested all the cases, the design is allowed to work. The out pattern task, okay, is coded many times inside this test bench. So the defining of task can save many coding effort. Yes, define once and use many times. And if there is any bug inside this body, we can just change here. Yeah. So you don't need to change here, and there. Okay. Okay, that's all for this section. Thank you.